Okay, so we wish to compute the scalar line integral of xy along the path which is a line segment going from 0, 0 to 1, 1. So if we ask ourselves what it is exactly that we need to know here, if we have a domain and we have a path in that domain, and we want to compute a scalar line integral of a scalar function f along C, then we have to parameterize the path with a vector valued function whose trajectory happens to be that path. And then our integral will be equal to the integral from A to B of f of r of t times the speed. So also, when we go from a point AB to a point CD, and we want to parameterize the line segment, then the parameterization can be 1 minus t times AB plus t times CD for t running from 0 to 1. So these are the things that we need to remember. And with these things in mind, let's proceed to first parameterize our path. So it's going to be r of t is equal to 1 minus t times the vectorization of the point 0, 0 plus t times 1, 1. And this will end up simplifying to t comma t. And t here runs from 0 to 1. And then we need to identify our function. Our function is xy. And we need to pull back, if we like, the function to the domain of the parameterization. So that's f of t comma t, which is going to be t squared. So finally, what we have to compute, we certainly need to compute the speed, as we can see here. So the velocity is simply a constant vector 1, 1, and the speed is nothing else but the magnitude of the velocity, which is square root of 2. So when we put everything together, we'll have the integral from 0 to 1 of t squared, which is f of r of t, times the speed, which is square root of 2, dt. So this will be t cubed over 3 times square root of 2 from 0 to 1, making this square root of 2 over 3 being the value of the scalar line integral.